Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study the pin diagram of 8251 Programmable Communication Interface, which is also known as Universal Synchronous Asynchronous Receiver and Transmitter, that is USART. So let us start with our topic. This 8251 Programmable Communication Interface, also known as USART, it acts as a Universal Synchronous Asynchronous Receiver Transmit. In the case of transmission of data from the microprocessor to the peripheral devices, this USART, it converts the parallel data into the serial data so that it can be transmitted to the peripheral devices. And in the case of receiving the data, it converts the serial data into the parallel data so that it can be computed on by the microprocessor. So we can say that the 8251 So it is also an USART which is used for data communication. So 8251, it receives parallel data from the CPU and transmits serial data after the conversion. This device also receives serial data from the peripheral devices. So it also receives serial data from peripheral devices and transmits parallel data to the CPU after conversion. So this 8251, it is receiving parallel data and converting it into serial data. Also it is receiving serial data and converting it into parallel data. So it can perform both types of conversions also, and it is working as a receiver also and as a transmitter also. So here it is written that it is also an USART, receiver and transmitter, universally accepted by all the users, and it performs both types of transmission, synchronous data transmission also and asynchronous data transmission also. So this is just a general introduction of the 8251 Programmable Communication Interface, also known as USART. In this video we will study the pin diagram. So let us come to the pin diagram of 8251. This 8251 IC, it has 28 pins. So let's see the pin diagram, how these 28 pins of the IC, they are defined. This is the pin diagram of the 8251 Programmable Communication Interface. It is having 28 pins. One to 14 pins are on one side and 15 to 28 pins are on the other side. You can see that first pin and second pin and these 27, 28 and 8, 7, 6, 5. They are denoted as D0, D1, D2, D3, D4, D5, D6 and D7. These are the data lines. 8 data lines are there from D0 to D7 available at different pins of the IC. Then we have received. RxD is for the received data because it is acting as a receiver also and as a transmitter also. So it will have pins for receiving the data and for transmitting the data. So for receiving data, we have the received data RxD pin. We have Rx ready, that is receive ready. We have the RxC, that is receiver clock. Okay, so these three signals are for receiving the data: receive data, receive ready, and receive clock, receiver clock. For transmitter side, we will also have three signals: transmit the data, that is this is for transmitter clock. Then we have transmitter empty and then transmitter ready. So these three signals are there: transmitter clock, transmitter ready, and transmitter empty. So three signals are for the receiver and three are for the transmitter side. Then this is for the ground connection, and here we have the power supply VCC plus 5 volt available at the pin number 26. These are the power supply connections. Plus 5 volt will be connected here and ground will be connected at pin number 4. Then we have read and write signals because data will be either written into the 8255, also the data can be read from it. So it will have the write and the read signals which are coming from the microprocessors. So write is there at pin number 10 and read is there for pin number 13. Then we have CS bar. This is the chip select signal which is used to select this chip 8251. Then 12th pin is for control and data pin. Then we have pin number 16 for sync detector, sync detect and break detect. Okay. Then we have CTS, this is clear to send. Then we have reset pin. This is DSR, data set ready. RTS, request to send. DTR, data to request. Then these we have already discussed: receiver clock, VCC, D0 and D1. So these are how the different pins of the 8251 IC they are described. Let us study the function of all these pins in detail. So first we will start with the data bus. So in the 8251 IC we have 8 data lines from D0 to D7 present at pin number 27, 28, 1, 2, 5, 6, 7 and 8. Okay. Now these pins, they can act as input pins also and output pins also. That means that data can be received and can be transmitted. Okay. So here we can say that the data lines, they are both input and output terminals. Okay. Or we can say that this is a bidirectional data bus. Which receives and transmits the data. Okay, because it is an 8-bit data bus is there, so 8 bits can be transmitted. It is an 8-bit bidirectional data bus, so 8-bit data can be received and transmitted. Now the data which is received, that will be either the control words or it can be the status words. And the data which is transmitted, that will be it can be any type of data that is transmitted from the CPU. Okay. So it is going to receive the control words and status words from the CPU and it is going to send the In the control words they will be received and status words they will be transmitted. Okay, so the data which is received and transmitted, it can consist of control words also, status words also, and as an 8-bit data also. So we are using here the 8-bit bidirectional data bus for this purpose. Next we have the reset pin. This reset pin, it is available at pin number 21. And it is acting as an input terminal. Input terminal means that this reset pin will be given, this reset input signal will be given to the 8251 controller. So this pin, reset pin, when this pin is high, so a high on this pin forces the 8251 programmable communication interface into the idle state, or we can say the reset state. Reset state means that all the control words, command words, status words, they will be cleared out, and the 8251, it will come to its ideal position, idle state. It is not going to perform any functions, any execution will not be performed, and also it will come to its initial conditions. Okay, all the flags conditions and all the control words, status words, they will be cleared out. So when this reset pin is given, this reset signal is given to 8251, the device, it is going to wait for writing of the mode instruction. There are different types of control words in the 8251. One of them is the mode instruction. So when this 8251 will go into the idle state or the reset state, again to start its operation, it will wait for the writing of the mode instruction, that when this mode instruction will be written into the 8251, will be sent to it by the CPU, then it will start its normal operation again. Now the minimum width of this reset signal, it is of 6 clock inputs. Okay, so this was the reset pin. Then we have the clock signal. This is for clock input. It's an input terminal which is available at pin number 20. Okay. Now this signal, clock signal, it is used to generate the internal timing and the control signals. It will provide the clock signals for controlling the timing and control signals for the 8251. So this clock input signal, it is used to generate the internal device timing signals, and this clock input signal, it is independent of the RXC or the TXC, means the receiver clock and the transmitter clock, it is independent of both these clock frequencies. Now the frequency of this clock signal, it must be greater than 30 times the RXC or the TXC at the synchronous mode and asynchronous mode. When the 8251 it is working in the synchronous and asynchronous mode, so at that time the clock frequency of the receiver and the transmitter, it should be this frequency of the clock signal, that is 8251 clock frequency, it should be greater than 30 times the clock frequency of the receiver and the transmitter. Okay, also it must be greater than 5 times in the synchronous mode. When the 8251 it is working in asynchronous mode, into 16 and into 64, means if it is working in this into 16 and into 64 modes, so in these two modes the clock frequency, it should be greater than 5 times this frequency. Okay, so this is the specification that what will be the frequency range in the 8251. So this was the clock input available at pin number 20. Next we have the read and write terminals. This is for the write input. Okay, and then we have the read input also. So both these are the input terminals which are available at pin number 10 is the write and pin number 13 is for read. Now this write and the read, these two input signals, they are having a bar over it, means these are the active low signals. They will function when their value is 0. Okay, so when this is active low, so when this write signal is active low, then the 8251 it receives a signal for writing the transmit data and control words from the CPU into the 8251. So when this signal is activated, the data will be written into the 8251. This data, it can be the control word or it can be the transmit data, means the data which is going to be transmitted by the CPU to the peripheral devices. Now when read input, this is also active low. For reading the received data and status words from the 8251. So when this is active, the 8251 it will receive a signal for reading the received data and the status words from the 8251. So 8251 that will be read, status words will be read, and the data which is received from the peripheral devices, that will be read by the microprocessor from the 8251. So read operation is performed when this signal is active and write operation is performed when this signal is activated. Next we have the C or D bar input, which is known as control. C is for control and D is for the data. This is also for an input terminal, and in the pin diagram you can see this is available at pin number 12. So this pin, it can act for both. It can act for control also and it can act for data also. So these three signals, the write, read and the control data, these three signals will decide that the data which is available on the data bus, whether that data is the control word or it's an 8-bit data. Okay. So when this signal is high, means when its value is 1, then command words and status words are available, and when its value is 0, then data is available. So we can say that when 8251, if this C, D bar, this pin is low, data will be accessed. And if C, D bar it is high, then command or status words will be accessed. So this pin decides that whether the data, that is the command word or status word, or an 8-bit data, it will be the data that is received or transmitted. Okay. The next terminal we have is the CS bar, that is chip select. This signal is also an active low signal, and it is available at pin number 11. Okay. Now this chip select signal, it decides that whether this chip is selected or not. When this signal is active low, it means that 8251 is selected, it is going to operate, and when this signal is high, then the chip is not selected, no operation will be performed by the 8251. Now the next pin we have is the chip select signal. So, and this signal is available at pin number 11. Now this chip select signal, it is used to select the pin. If this is active low, because it is having a bar over it, so it's an active low. When it is low, means its value is 0, then the 8251 chip, it will be selected, and when it is high, then the chip will not be selected. So if we want to perform any task with the 8251 IC, we have to first select this pin. So this 8251, it is going to work only when this chip select signal will be given to it by the microprocessor. So when this is an active low input terminal, it will select the 8251 when the CPU access this chip select signal, and when this is high, the device won't work, that 8251, it is not going to work, it will not be selected by the CPU. Now the next pin in the pin diagram we have is TXD, that is the transmit data. Okay, now next we will study the pins which are for transmitting the data, that is TXD, then TXMT and TXE, that is the transmitter clock. All these are the output terminals because the 8251 it is transmitting the data to the peripheral device. So these pins they will act as an output terminals. So first we have the transmit data which is available at pin number 19. So this TXT it is an output terminal for transmitting the data from which the serial converted data is sent out. Now when the microprocessor it is sending the data to the 8251, it will send a parallel data. Now this parallel data will be converted into the serial data so that the 8251 it can further transmit that data to the peripheral device. Okay. So this serial converted data it is available at this pin number 19, that is transmit the data. Now the device is in mark status when this transmit data it is at high level, after resetting or during a status when transmit is disabled. So this can be done by writing the status and the command words. We can write the control word in the form of command. We can set the mode and we can enable this transmit data pin. We can also disable this by the command words only. Okay, so this pin can be enabled or disabled by using the command words. When this is enabled, then the data is going to transmit by the 8251. When this pin is disabled, then no transmission of data will takes place. So this pin is basically used to enable or disable the transmission of data. Next transmitter pin we have is TXRDY. This is for transmitter ready. Okay, and this is available at pin number 15. You can see here we have TX ready. So this is at pin number 15. So this TX ready pin, it is an output terminal which indicates that the 8251 communication interface, it is ready to accept a transmitted data character. Okay, that transmitted character will be given by the microprocessor to the 8251 and then it will transmit it to the peripheral device. So this is just giving an information to the CPU that it is ready to accept that transmitted data character. character. But this terminal, it is always at low level if the CTS pin, that is the clear to send pin, that is at high, or the device is in TX disabled status, means that transmission of the data has been disabled, or this CTS pin it is high, then TX ready will be at the low level. Okay, because this can be done by using a command word. We can write a command in the control word, so that command is going to disable the transmission. So when transmission is disabled, then this pin is also disabled, this pin will be at low level. So this TX ready, it will be low if the clear to send command, means that pin is high, or the transmission is disabled by a command. Now this transmitter ready signal, it is indicating that the transmit data character, it is ready or not, means it can be received or not. Okay, it is regardless of the status of this CTS and this TX disabled command. Okay, this is just indicating that the transmitted data that is receivable by the 8251 or not. So we can say that TX ready indicates is receivable or not. Now this if the microprocessor it writes the data into the 8251, then this TX ready it will be reset. When the CPU has written that data, then TX will be again reset, it will be made low by the leading edge of the write signal. So we can say that if the CPU writes a data, so if the CPU is writing the data character, the TX ready signal, it will be reset by the leading edge of the write signal. So that was the transmitter ready signal. The third signal for the transmitter section is the transmitter empty, that is TX empty, which is available at pin number 18. So this transmitter empty, this signal indicates that the 8251 USART, it has transmitted all the data characters. Now no data character is available with it and the transmitter is now empty. Okay. So to indicate that the transmission of all the characters has taken place, this signal will be made high. Okay. Now this transmitter, because it can transmit in the synchronous mode also and in the asynchronous mode also. So in the synchronous mode we have along with this data characters, we have the sync bits also. So in synchronous mode, all the data character bits plus the sync bits, they are automatically transmitted and the transmitter is now empty. No data character is now available with it. Okay. So in synchronous mode, So in the synchronous mode, this terminal is at high level if the transmit data characters are no longer available with the transmitter, plus the sync bits are also automatically transmitted. Now when the microprocessor it is writing the data into the 8251 IC, so it is going to activate the write signal. So write signal will be activated when the CPU is writing a data character. So this write signal, it will also reset the TX empty and the TX ready signal it is going to make high. TX empty because it was indicating that the transmitter is empty, but now the CPU it is writing a data into the transmitter, so at that time this TX empty it will be reset. So this signal TX empty it will be high when the transmitter is empty, no data character is available with it. But when the microprocessor it will write the data into the transmitter, then again this TX empty signal it will be at low level, it will be reset, okay, and it will be reset by the leading edge of the write signal. Now in this thing, one thing should be noted that this TX empty as the transmitter it can be enabled or disabled by using the CTS command, which is clear to send. If this command is high, if this pin is high, then the transmitter will be disabled. Now when this pin is given or when this transmitter disabled command is given, before that if any data character has been already written into the transmitter, then that data byte will be sent out to the peripheral devices, and after disabling of the transmitter, if any data byte is written, then that data byte will not be transmitted, it will be holded by the transmitter only. So when this CTS is high and transmitter is disabled, data written before disable will be sent out. TXD and TX empty will be at high. Okay, so when data is written before the disable, it will be sent out, and the transmit data and transmitter empty, these pins will be at high. Now if the data and the TX empty pin, it will be at the high position. So this disabling of the transmitter, if data is written before that disabling, the data will be sent out, and TXT, TX empty, they will be at the high position. And if data is written after disabling of the transmitter, then that data will not be sent out, but the TX empty, it is still at the high level. Okay.